Reference students. Uh, now the unit number 4. Today we discuss about this image compression. So what are the basic fundamentals of image models, image compression models, elements of information theory, error-free compression means Huffman coding, arithmetic coding, and wavelet transformation based coding. Before that compression topic, what is a major role for image compression? That is the role of image compression, the art and the science of reducing the amount of data required to represent an image is one of the most useful and commercially successful technology in the field of digital image processing. That is, image compression is a major thing to compress or reduce the size of this data. That means data means image. So here there is a number of images that compressed or decompressed daily is staggering, and then the compressions and decompression themselves are virtually invisible to the user. Everyone who owns a digital camera, surfs the web or streams the latest Hollywood movies over the internet benefits from the algorithms and the standards. What are the standards? Image standards. Okay, we discussed in this chapters. What this is JPEG or bitmap picture moved to this lot huge amount of size, but JPG joint photograph expert group format, standard format, compression format reduce this size. So in this techniques we will come to say this a compression model. So this is this major role for fundamentals of this image compressions. So first of all, this the term of data compression refers the process of reducing the amount of data required to represent the given quantity of information. In this definition, data and the informations are not the same. Data are the means by which information is conveyed, because the various amount of data can be used to represent the same amount of information. A representation that contain irrelevant or repeated information are said to contain redundant data. So if we let B and B dash denote this number of bits into two representations of this same information. The relative data redundancy means or represented by the B bits will come to say this R equal to 1 minus 1 by C. So where C is commonly called a compression ratio. C equal to B divided by B dash. Already number of bits, we say this B and B dash. For example, C equal to 10 means sometimes we written as a 10 is to 1, the ratio, compression ratio. 10 bits of the data, every 1 bit of data to smaller representation. The corresponding relative data redundancy, larger representation 0.9 means 9 or redundancy rate equal to 0.9. So indicate this is 90% of the data will be come to reduce redundant. So in this coding will come to say this identification, the types of data redundancy, the coding redundancy, spatial and temporal redundancy, and irrelevant information. So coding redundancy means a code is a system of symbols. That means symbols mean letters, numbers, or bits, and like that. So on. Will be represents the body of information to a set of event. Each piece of information or event is assigned the sequence of code symbols called the code word. Code word, it is this length. The 8-bit codes that are used to represent the intensities in most 2D intensities arrays. The spatial and the temporal redundancy will come to say the most of the pixels of most 2D intensities array are correlated spatially. That is, each pixel is similar to or dependent upon this neighboring pixels. You say this irrelevant information, most 2D intensities array contain the information that is ignored by the human visual systems. So this is the computer generated to 25 by 25 into 8-bit images. The first thing is coding redundancy. A. and B is the spatial redundancy. So here this is the original background of this image. Is this some type of unwanted information, this line information. Here no image of background, that is only from spatial redundancy. The C information is a irrelevant information. So no need of this background image. Only uh, plain color. So coding redundancy, already told about this, what the information will be like that, it will be representation from mathematical representation. So in this random variable Rk is the interval between 0 to n minus 1 is used to represent the intensity of an m by n images. And each Rk occurs with the probability Pr of Rk. So Pr of Rk equal to Nk divided by Mn. So where N is the number of intensity values and Nk is the number of times that the kth intensity appears in the image. Each of the representation of each value of this Rk is L of Rk. The bits of each pixel L average equal to sigma k equal to 0 to n minus 1. L of Rk and Pr and Rk. That is the length of average length of this information. Regarding this, each and every natural m bits fixed length code. So this is L average, and then what is the information among this particular rules. So here this illustration of the variable length of coding. For example, to identification between this L average. So L1 and Rk equal to 8 bits of all Rk values. And how to identify this L average value? L average equal to 0.25 into 2 plus 0.47 into 1 plus 0.03 into 3 equal to how many bits? 1.81 bits. Will be representation from, that is his example. The total number of bits will be needed from MNL average 56 into 56 into 1.81 bits, or 1,18,621. The redundancy of relative redundancy will be calculation here. C equal to 256 into 256 into 8 divided by the total number of MNL average equal to 8 divided by 1.81, approximately 4.42 compression rate. And then redundancy will come to calculation 1 minus 1 by C will be 1 divided by 1 minus 1 divided by 4.42 equal to 0.774 redundancy. That means 77.4% of data in the original 8-bit 2D intensities array is redundant. So this is an example will be calculation from the type of this value of this coding redundancy. So example of variable length of coding Rk, that's the case 87, 128 and then 186 or 255, that is the length of this variable k length. And then the calculation Pr of Rk and the coding redundancy code 1 and L1 Rk and the code 2 and the L2 and the R2 Rk. And the spatial and the temporal redundancy to be representation from the type of the information of a 2D intensity array. So in this information, all the information histogram is uniform, because the intensity of the each line was selected randomly. It is its pixels are independent, because the pixels of actually will come to say this the type of horizontal directions. The intensity histogram of the image in the type of like that is information uniformly to equal length of this information, run length pair. So this is the temporal information. Maybe this mapping will come to say this type of information transformation techniques for irreversible of this map. So irrelevant information is one of the simplest ways of a compression of the data. So remove this superflows of data from the search. In this image, you will come to say this each and every image will be representation from original into dimensionality into some type of 8-bit intensity values. Some type of redundancies will come to analyzation from the type of normal of relevant informations. See here, there's a histogram of image of the histogram equalization from this version of this image. So in this quantization, what is the technology will come to using from that word, which generally to mapping of a broad range of input values. So how to this measuring of image information? Basically, the image information, the representation from the type of information theory. So in this manner, from random event E, probability will come to calculation here P of E is said to be this I of E. So image information representation from the type of I of E equal to log of 1 divided by P of E equal to minus log of P of E, and P of E equal to 1 means I of E equal to 0. So no information is attribute to be they occur from what is the information to communication to transfer from the type of the values. So each and every value of the entropy will come to calculation from H equal to minus a sigma j equal to 1 to j P of A of j and the log of P of j. Here we come to say the type of information of probability. The zero memory imaginary will come to analyzation from intensity of source. The intensity source of entropy becomes S dash equal to minus sigma k equal to 0 to L minus 1 and PR of Rk and log 2 and PR of Rk. So in this algorithm will come to substitute from the type of probabilities from that is value. We got this approximately 1.6614 bit per pixel. So another type of information, Shannon's first theorem to be supported from the type of coding theorem. In this error-free algorithm will come to supported from fidelity criteria. The Shannon theorem, signal noise ratio and root mean square error to be pointed from the type of measurements of the cases from worse and worse, slightly worse, the same, slightly better, better, and much better. So these are the evaluation depends upon this value of a range. So in this allocation from excellent, fine, and possible, and marginal, inferior, and unusable. So many image compression models are there. Image compression system is composed to distinct functions with components and a encoder and a decoder. The encoder performs this compressions. The decoder performs this complementary of these operations of decompression. Both operations can be performed in software. In the case in web browser, so and many of the commercial image editing applications are in this combination of hardware and firmware. As in the commercial DVD players, a Kodak is a device or a program that is capable of both encoding and decoding application. So here this approximation of this image like that is this how to this encoding and decoding application. So here this functional block diagram of this general image compression system f of x comma y or f of x comma y comma t, that's a mapper and quantization and a symbol coder. How to this compress the data for storage and transformation, like that is encoding, and then the symbol decoder and the inverse mapper is like that decoder. F cap of x comma y or f cap of x comma y comma t. So the input image f of x will be fed into this encoding and create the compressed representation of this input. Like that, there will be compression to be sometimes will come to error free. The compression system sometimes will produce the error free compression, lossless compression, or information preserving compression. If not, this reconstruct this output image is distorted, or and the compression system is referred to as lossy. The encoding or compression process. The error, the encoder designed to remove these redundancies described in this previous sections already told about here this. What is the first stage of encoding processor mapper? Transform this to any type of amplitude functions of f of x comma y Usually, the non-visual or any format designed of this reduce the spatial and temporal redundancy. The operations generally is reversible and may or may not directly to reduce this amount of data required to represent this image. Run length coding is an example of mapping. Normally yields the compression in the first step of the encoding process. The mapping of image into the set of correlated transformation coefficient is examples of opposite of these cases. In the video quantization, video applications, what is the mapping from previous cases? What are the some cases or features? Video frames or facilitate or the removal of a temporal redundancy. The quantizer is a reduced this accuracy and the mapper output and accordance with the pre establishment fidelity criterion. So the goal is to keep irrelevant information out of this compressed representation. As noted earlier, this operation is irreversible, and then what is the omitted of error-free compression is desired. In video application, the bitrate and the encoded output is often measured in bits per second and is used to adjust the operations of the quantizer. So like that, this decoding decompression process is similar to the same of the encoding, but this is a simple decoder to inversible of this mapping. Inverse means that is what is a major role for error-free compressions. Like that, we study about this Huffman coding. So a lot of image formats or format standards are there. Here this is image format. We will come to study about this so many international standards. International Standards Organization ISO, International Electrotechnical Commission IEC, and International Telecommunication Union ITU-T, United Nations UN, and then Consultative Committee of the International Telephone and Telegraph CCITT, and then video compression standard is a VC1 by the Society of Motion Pictures and Television Engineers SMPTE, and AVS by Chinese Ministry of Information Industry MII. So in this standard, we say this image compression standards, formats and containers, still image and a video image. Still image is like that binary. So already told about what are the formats of these groups of this picture. Tagged image file format TIFF and the joint photograph expert group that format of a continuous store, binary and a continuous store. Continuous stored image will come to say bitmap picture, um, graphics image format GIF, and a PDF portable document format PNG, portable network group PNG, and a tagged image file format web portable, that is come to continuous format. The video format AVS, STV, and JPEG, motion JPEG, and a QuickTime VC1 and WebP. This concept will come to say the type of different type of standards. So in this name and bi-level and still images, will come to say the type of continuous image. It will say the name and organization IEC. So in this concept, we'll move to the type of Huffman coding. So one of the most popular techniques for removing coding redundancies due to Huffman coding, Huffman in year 1952, encoding symbols of information source individually. Huffman coding yields the smallest possible number of code symbols per source. In this terms, we'll come to say that first we'll say Shannon theorem. The resulting of the code of optimals to fixed was the value of n, and the subject to this constraint that the source symbols coded one at a time. So here they say there's a type of continuous tone, BMP, graphic interchange for file format, the interchange for graphic interchange format, PDF portable document format, PNG portable network graphics, tagged image file format. Here the WebP support for lossy compression. Here they say AVS, audio video standard, and high definition video STV, and a motion JPEG, and then QuickTime you'll come to say that type of a VC1 and a WebP. You'll come to so many standard format till the first step of upman code. So what is the main approach of this upman code to a series will come to reduction by this ordering the portabilities of the symbols. Under consideration, the combination of lowest portability of the symbols. So in this figure, we gave array of augment code to be construction from the type of information. Hypothetical set of the source symbols to be probability range will come to reducing from the source reduction. The bottom two probabilities 0.06 and 0.04 and the combined form this component symbols of this 0.1. And the compound symbols will be associated of probability or place the first source reduction column so that the probabilities of the reduction source also are ordered from the most of the least portable. So in this symbol, the two symbols of far right of the reaching of the second step of human up and code procedures. In the reducers are starting from the smallest source, working back to the original source. The minimal length of the binary code of two symbols, zeros and one, as in this figures will come to analyzation from the type of working of arbitrary, the assignment. So in this average length code will be calculation here 0.4 into 1 plus 0.3 into 2 plus 0.1 into 3 plus 0.4 1 into 4 0.06 into 5 0.04 into 5. So approximately the length of this code is average 2.2 bits per pixel. The entropy range will come to 2.14 bit per symbols. The Huffman code will come to the original source. Here is the symbol A2 to A5. The probability range is there. They are given to arranging this first source reduction, second source reduction, third source reduction. Finally, there is a fourth source reduction is a symbol come to 0.6. So after the upman code assignment procedures will come to reversing order in this reduction 0 and 1 to reverse order. Finally got this code. The codes will come to the uniquely decodable format. Left to right manner will come to analyzation from the figure left to right scan. The symbol should become to corresponding information to representation A1. The continuous of this minimal decoding message is A3, A1, A2, A2 and A6. So the Huffman coding of this using this code MATLAB implementation of MATLAB code procedure encoding with 7.428 bits per pixel. The Huffman code table should be required for this calculation among this range of this original 8-bit fixed length how to be reductions of redundancy will be removed. So another coding symbols will come to say Huffman coding, arithmetic coding. We'll be discussing in this next method. So this arithmetic coding will come to the unlike the variable length coding, the previous two sections arithmetic coding generates non-block codes. In arithmetic code will come to this work with the one or two corresponding between these source symbols. It will come to calculation among these zeros and one. So each symbol of a message reduce the size of the interval in accordance with its probability of occurrence. Because the techniques does not require, as does the Huffman approach, that each source symbols translate into integral number of code symbols, that is, the symbol be coded one at a time. It achieves, but only in theory, the bound established by Shannon's first theorem. So here, yeah, 5 symbols of the sequence or message A1, A2, A3, A3 and A4, and the two signals will come to this representation from the type of information narrative the range, and the narrowed range is subdivided in accordance with the original. Source symbol A1, A2, A3, A4 and 0.2, 0.2, 0.4 and 0.2, the initial sub-intervals will come to 0.2 to 0.2, 0.0 to 2 to 4, 4 to 8 and 8 to 10. The arithmetic coding will come to this probability range of coding encoding procedure A1, A2, A3, and again A3, again A4. Finally, you come to say this the type of source symbols. So this is this adaptiveness of context dependent of probability models based on this arithmetic coding. This is this input symbols, the context determination, probability estimation, and then arithmetic coding. So input symbols will be inputs. What are the symbols and context should be separable from based on this probability, and then symbol probability will be continuity from arithmetic coding, and the reverse of this updated probability of a current contestant. The code bits will become to generated because that's context means A, that is the connected of the symbols being coded, and each and every time the context became being coded from the particular information, and finally the context with one symbol coded CAD and EB. How to be this is generation from the type of arithmetic coding. So in this Debug compression standard, which contains the option both Hoffman and arithmetic coding, typical to support from Hoffman coding alone. And the next coding format is this wavelet transformation based coding. So many coding methods are there, and with only three important uh, format of compression: the Upman and arithmetic coding, and then finally the wavelet coding format. So wavelet is one of the important transformations concepts. Here we to apply from the type of one of the compression standard we applied. So here study from so many BTCs are block truncation code. It's also is one of the important coding methods. So now wavelet is a fourth unit last topic. We discussed in this main major role from wavelets. So wavelet coding. So each and every block transformations with the techniques, each and every information to require from the transformation along with the coefficient. In the case of transformation of basic function is called wavelets. The wavelet is come to consider from this coding, typical coding, the encoder 2 power j into 2 power j image. The analyzing of this wavelet sigma, sky, and the minimum decompression levels j minus p. The selected of this computed or discrete wavelet transformation of the image, wavelet has the complementary scaling function sky, and then it will come to by the fast wavelet transformation can be used. So in either the computed transformation converted large portion of the original image to horizontal. In this Laplacian will come to analyzation from any type of information like that run length or any type of lossless coding method, run length on Huffman and arithmetic and bit plane coding can be corresponding into final symbol coding steps. So in this wavelet coding transformation is here this input image wavelet transformation quantizer symbol encoder. This is a compressed image, and after compressed image will come to decoder, symbol decoder, and the inverse wavelet transformation. Again decompressed image will be that. So what is the main selection over to wavelet information? So correspondingly the type of wavelet, the impact of directly and computational complexity of the transform, and less directly the system ability to compress and reconstruct the images of acceptable error. So most widely to use to expansion of the functions of wavelet based compression to be supported from reconstruction from filters. So here this is a wavelet, Hor wavelet, and Tabachi wavelet, and Simlet wavelet, and bi-orthogonal wavelet. So filter tapes will be depends upon scaling and wavelet concept. 2 plus 2, 8 plus 8, 8 plus 8, and 17 plus 11. And zeroed coefficient is this to 33.3 percentage to 42.1 percentage of a wavelet transformation. Zeroed coefficient. Here this three scale wavelet transformation of the with respect to this Hor wavelet and Debussy wavelet and Simulate wavelet, and then Coganen and combined with Debussy and a few and Bio by orthogonal wavelet formats. So finally, we come to say the type of information almost to be compressed in the potential range, the increasing almost 10 percentage of the compression to be produced. The decomposition level selections also be the same informations regarding to determine of the transformation of this level. Quantizer design, the two important information become to quantization due to the large quantization interval level around zero called dead zone, or adaptive from the type of the information from the quantization interval from scale to scale. The decomposition level of impact on a wavelet coding 512 into 512 image of figure 8 point level. The decomposition levels will come to filter bank iteration 1, 2, 3, 4, 5, 6. The what is the major role for approximation coefficient image is the dimensionality, and say that truncate coefficient, and then error of RMSE levels, root mean square error. So in this type of information like that, the information regarding from any level of truncate coefficient, approximately 95.6 in this highest from 32 by 32. That level of a range come to say that 97.918. The impact of the dead zone interval selection on wavelet coding. Dead zone threshold depends upon the root mean square error, coefficient truncation, and then the root mean square error of intensity levels 0 to 18. So this is this RMSA reconstruction about this error. Normally that is a threshold level 18, where the number 0 reached for 93.85, and the percentage would be this increasing 97.92. So now I'm finishing this compression level of image standards. Uh, Thank you.